This briefing provides a summary of the condition-based maintenance tools that Data Fusion and Neural Networks has developed over the past 5 years. A more detailed version of this is available from Jason Hines at NAWC. Basically, the technique learns normal behavior for a C-130 engine data and then flags on abnormal behavior. We also automatically label and categorize the abnormal conditions, then provide trust scores on the outputs. Once we have done this, the smoking gun tools then learn the correlations of these abnormality conditions to the remiss repair data. And from that, we can goes to the user to recommend valid repairs. We have over 40 years experience in providing data fusion and neural network machine learning applications for the DoD. And we have more recently achieved TRL level 7 at 3 SOPs for the WGS satellite, ingesting state of health data and finding unknown abnormal behaviors there and categorizing those, as well as for the third SES, receiving satellite real-time state of health data, again, detecting and doing indications and warning for various conditions on satellites there. We also have a NSDC, a certification to field there for detecting abnormal catalog updates into the space catalog and categorizing those, participating in the SAC-T exercises in support of NSDC. We also have sold licenses to Aerospace Corporation for applications for GPS abnormality conditions and warnings there. We have a patent on the abnormality detection and classification, as well as one in process now for the trust networks. Our objective is to find known and unknown precursors to anomalies on any instrumented system. And once we find those, do correlations of those anomalies, historical repairs, so as to recommend condition-based maintenance. The operational impact of this is to reduce the cost of maintenance over preventative and corrective maintenance approaches. And this technique can be used for any naval platform or any instrumented machinery. To solve this GCPM problem, we needed to provide 6 innovations. The first is, how do you get a neural network architecture and training accomplished for any system from hundreds to tens of thousands of measurans and learn normal behavior, then flag on abnormal correlations in the data? We do this with a DMSRT set of neural networks that we've been developing over the last few decades by growing the neural net to be the smallest possible to achieve the errors required by the user. The next problem we had to solve was how to learn these correlations with supervised training. Most people use unsupervised training to solve this problem. And we did that with a patented ICA approach, which is in the longer version of this briefing. And the third problem we had to solve was, what signatures do you use for the categorization, and how do you automatically label those signatures? And so we use the output of these ICA nets, those signatures, rather than the raw data signatures, because they better separate the precursor abnormalities for automated categorization neural net training. The fourth problem we had to solve was, how do you know when you go operational with this that the data you're applying these nets to is similar to the data you trained and tested and validated on. And so we had to train a set of trust neural networks that will tell the user when these nets are being applied to data that's completely different than the anomalies and precursors that we have trained before, so that he knows he can't trust prior categorization. But we also provide whether it's an unknown new abnormality and categorize it and find the most similar categories. The fifth problem we had to solve was to take these precursors and discover correlations to all the previous repair data. When those precursors occurred, what repairs were needed, and then provide a user GUI to allow him to validate which repairs to recommend based on the precursors detected in real time. Then the last problem was how to have the system evolve so that the system automatically determines when to retrain, what to retrain on, what to test on, and when to promote to online operations. And all these solutions are in the toolbox that we have delivered to the Navy. Under this AIMS Phase 2 effort, we have delivered a prototype that does GCPM on C-130 engine and repair data. We are looking to get an ECP from a naval organization that has either other naval aviation data or another instrumented machine data for which they would like to do condition-based maintenance. The benefits of condition-based maintenance are the reduced maintenance cost, to reduce the number of preventative checks that would be normally going on, and therefore saving labor hours, and also increasing mission availability of the aircraft. There's also a savings due to overcorrective maintenance due to the reduced number of mission aircraft failures due to the precursors that condition-based maintenance finds. We have proven this capability on satellite state of health data out at Schriever Air Force Base, also on CNC machines out at Warner Robins Air Force Base, and also on space catalog data to finding abnormal space catalog updates to indicate for warnings for the Air Force. Under this Phase 2 effort, we delivered a containerized version of the AIMS software ready for operationalization fleet-wide, and it has the ability to be flexible to any data set coming in. It's because it's data-driven and then it's goal-driven for improved operations with use. We've also sold licenses to Aerospace Corporation for use for NASA for the GPS satellite for finding abnormal RFI on GPS, and then providing warnings for NASA and the DoD. Our plan is to operationalize AIMS within the DoD and also to commercialize via software licenses. We've already started this process out at Schriever Air Force Base, where we have a certificate field at MSDC for abnormal catalog update detection and categorization, and also out at the 3rd SES, where we have installed AIMS, a NOM-based software for satellite state of health abnormality detection and categorization, and applied it to exercises there. We have also sold licenses to Aerospace Corporation, where we are applying a NOM/AIMS for abnormal GPS behavior detection and warnings. The next phase of this SBIR Phase 2 is the ECP, where we now are able to provide a sole source application of this AIMS technology to any potential customer who has instrumented data for which you would like condition-based maintenance, abnormality detection, and recognition applied. Thank you.